All right, we're given a function f that is continuous from -4 to 4, and we're given a graph that is conveniently geometric, and we are asked for the average value of f on this interval, right? So it's really helpful to know the average value function of a function formula, right? So it's 1 over b minus a, and then the integral from a to b of whatever function you want the average value of, right? If you know this, then this is basically about doing 1 over 4 minus a -4, and then calculating the geometric area of this curve, right? So common mistakes, people are not going to have that 1/8 in front. So there's a solid chance that if you were guessing, the wrong answer that a lot of people are going to choose is accidentally 8 times the right answer. So there's a good chance that the wrong answer is conveniently 8 times the right answer. So I'm going to go ahead and go out on a limb and guess that this is my answer. I'm going to guess that it's this one, and I'm going to guess that this answer is the trap because it's 8 times bigger. So let's go ahead and see what happens, but that's just my going out on a limb, taking a guess on what the AP would do to try and trap you. So let's go ahead and find this area, right? If we're integrating from -4 to 4, these areas are going to be positive, right? Positive, and then you're probably doing this separately as a trapezoid, like those are all going to be positive areas, and this area is going to be negative, right? So this positive area has a height of 1 and a base of 2, right? So that's 1/2 the base times the height, right? Uh, and actually, let's just do all the positive areas first, right? This one is a 2 by 2 triangle, so that's a 1/2 base times height, right? And then this is a trapezoid. There's two ways to do this. You could either do it as a trapezoid with a base of 1 and a base of 2 and a height of 1, or you could just recognize that this is a box and then this is literally a half a box. It doesn't matter. So this is 1/2 the height of 1 times the sum of the bases. Either way, you get 3 halves. So this is 2 halves, right? And this is 4 halves, and this is 3 halves, right? And if you wanted to not make them halves, that's fine. And then this one down here, this has a base of 3 and a height of -2. So this is a 1/2 the base times the height, and notice that it nets negative, right? And that seems to be a -6 halves, right? So if you were going to put all of these together, it looks to me like I have 6 halves and 3 halves and -6 halves, right? If I put all of these together, seems to me like the 6 halves and the 6 halves go away, and I get that the total area, that this whole integral is a 3 halves. And I think that my gut instinct checks out, right? So this is a 3 halves. So I think I get 1/8 times 3 halves, and sure enough, 3 halves was the trap answer, and the 3/16 is the right answer. I certainly wouldn't have just gone on my gut to answer that on an AP, but as you do a lot of these problems, you can sort of start to anticipate where the traps are going to be.